On today's Maker Mashup, an introduction to the X301 CoreXY 3D printer. So today's video is an introduction to the X301 3D printer build. And in the coming days, we will have the very first assembly video. But both Nick and myself felt that we wanted to put together a little bit of a video. Originally, he was going to be on site assembling the printer with me, but due to social distancing, right now that is impossible. So we wanted to put together a little bit of a video as an introduction to let you know what you're getting into in building the X301 printer. So in today's video, we're going to be covering how you can source your parts, a little bit of history about the printer, and we're also going to be covering things like how you can modify this printer for your own individual use. So with all that said, let's bring Nick on and we'll talk a little bit more about the X301 and what you can expect in building this printer yourself. Okay, so thanks, Nick, for jumping on here in StreamYard. We wanted to go ahead and do this together. I know we originally were planning on building the printer together, but social distancing has kind of put that to a halt at the moment. But definitely want to proceed with putting the printer together and get those videos out there. So for those people that are watching, what we wanted to do here was a little bit of an introduction video. And I talked a little bit about that earlier, but what we want to do is just kind of talk about what you're up against in building this printer, a little bit of history of the printer, some of the design that we put into it. But overall, just to give you kind of a really good feel for where you're going to need to go next in order to build this and follow along with the series. So Nick, I know it's been a long year that we've worked on this printer. It's hard to believe it's been a year, but we've worked on it for the last year, and I think it's really come to fruition and been a really great project. Um, why don't you talk a little bit about how we got started? I know I talk about it a lot, but why don't you talk a little bit about how we got started in doing this? Obviously, we've been together and friends for a long time, and this was really a great project.
Yeah, so I mean, the earliest days of this printer were, I think you had originally started printing some extrusion in
It
plastic, which
is
was
it is on
interesting.
plastic. Yeah.
Yep. So I think some of the earliest kind of just brainstorming and ideas was done with that, putting that together, seeing okay, how strong is that? Like, what can you design with that in mind? So I know some of the earliest ones were more of kind of a standard cube style printer. We then brainstorming just different ideas, things we wanted to change, and we went through a few different ideas. But I know, ultimately it's similar to a cube, but I think that, the front is a little more open, and just some. It's kind of simple in that regard, and the footprint is a lot smaller than I think some of the other hypercubes and things of that nature. They tend to be a little bit bigger footprint. And we try to make things as compact as possible without, sacrificing the kind of the build volume we are looking for.
Yeah, I think that was one of the big challenges. I know that when I'd put some of the original prototypes together, even before we had the first working prototype one that I'd used for better part of 6, 7 months. I know that the bed and trying to get that large bed in such a small frame was a big challenge of yours, being one of the design elements that you took on, which was really putting together the frame in CAD and then going ahead and getting that bed to fit.
Yeah, yeah. I mean, that was for me. It was kind of a learning experience on the CAD side. So using Fusion and I tried FreeCAD. I didn't have a ton of success with that. So yeah, I ended up doing it in Fusion, but I put together the entire printer essentially in CAD. The assembly and everything, all the extrusion, all of the hot end, carriage, X, Y, Z, all of it, including the bed and everything. I put it all together, and then as part of that, I then kind of designed a bunch of parts. So pieces, little adapters to connect the bed to the Z-axis, bits for the CoreXY system itself. So all of those pieces are kind of printed parts that I designed, and then you know different pieces of inspiration here and there. But for the most part, it's kind of different in that regard. A lot of designs I saw put things inside the printer, which is why they have such a big footprint. I decided to go out, kind of around, which means you've got a little bit more on the outside and the top, but overall it's a little bit more compact as far as what's on the desk. So.
Yeah, and it's interesting when you talk about different inspiration for the printer and things that took place. I know that we had that open front on the printer originally when we were still working on it with plastic extrusion, and that open design was, I think, one of those inspiration things where, if I remember correctly, you and I were talking about, it, and you're like, "Hey, just turn that around, and then we can make
Mm.
it completely open." And with a little bit of work, we developed that very open front, and it's, to me, it's kind of a signature of this printer of being so open in the front, where, as you mentioned earlier, there's a lot of cube shaped ones, but I think that the frame and the stability, and I think the prints really speak for themselves with that open design. So I think it's been a very cool feature of the printer.
Yeah, no, I definitely agree, and I think there's a lot of room in the design for you can make bigger ones. I think you add a bit stronger extrusion, bit bigger pieces, that kind of thing. But I think the design is pretty scalable. I mean, you could scale it down, scale it up, to whatever you need. I think on a bigger version, maybe you look at multiple extruders, that kind of thing. I know originally we had more of a Bowden design, just being from our familiarity with that. But I know on the recent ones now we've switched to direct drive, so I think there's been some noticeable improvements from that. I know you're running a Volcano and things like that, so I think overall, like, some of those choices are going to be up to whoever builds it. I think the basic design is good, but yeah, I think there's just tons of flexibility as far as electronics and things of that nature go. And then if you want to scale it up, I think the basic design works. You just add a bit of extra structure where needed.
And that's probably an excellent segue to really the next part, now that we've talked a little bit about the history, which is what an end user or someone, a maker, is really getting themselves into with this. So I think one of the big keys is 3D printed parts. So you're definitely going to need access to a 3D printer to print the parts out. Uh, I know that you and I both chose carbon fiber for the filament, and we did that for strength. Um, Currently, I'm using PLA for that, but PETG, obviously, another really good filament to use. I would use carbon fiber PETG or carbon fiber PLA for the printer construction of the uh, pieces that have mechanical stress. So far, there's really only two pieces that I use that are TPU. The feed itself, just so it has a little bit more of a give and rubbery feel for the feet. And then the relief on the 3D printer bed, that's also TPU. So to really start with this printer, you should definitely be familiar with very tight tolerance parts, being able to 3D print a part that is, if you print it, the clearances on the parts are exact. So when you fit 20 by 20 extrusion in there, it really is 20 by 20 is that space in there. So I think one of the first challenges in getting this printer to build successfully is getting good quality 3D printed parts.
Yeah, and a lot of that has to do with just making sure your settings are good. Try to avoid elephant footing as much as you can. If that requires printing on a raft or something, just to get the parts to come out correctly. I mean, that's something you can do. I think, like you said, carbon fiber, I think, is a good, or the carbon fiber filaments, the ones that are filled, are a good way to go for final stuff. And then, I would say, though, you can likely get the printer up and running with something simpler than that as well. So, I mean, if you don't have a printer and you're just looking to get those parts basically printed, look around locally, see if anybody that has a 3D printer, see if there's any maker spaces in your area or any sort of companies in your area that do 3D printing even. They're more than likely able to do these for pretty cheap. And if they got PLA, and they can do it in that, that's fine. Get it together, and then you can always come back and reprint those parts. And that to me is the cool part, is you can, those parts are available, so you can always print them again, in whatever color you want. So you can just replace things as you go or what have you. But yeah, I think overall the printer works pretty good, even with like PLA. And then if you want to go really crazy, you can start messing with some nylon or something of that nature to even get more strength out of it. So, and I know they've got carbon fiber nylon too, which is even more insane.
So 3D printed parts are definitely the first challenge. I think the next challenge that someone's going to run into in building this printer is going to be sourcing the parts. So currently, you and I have not yet either decided to build a kit and provide it yet, or find a vendor that's going to do the kit. I know it's something you and I have worked on a little bit on and off, but of course the design of the printer and the channel overall has been the primary focus. So when it comes to sourcing the parts, I think as people work on this printer, they really need to think of it as their printer more than here's exactly the list and I'm going to end up with X product at the end. And I know that you and I have often sourced parts differently. I'll buy something off of Amazon because I want to get it quickly. You've purchased things from AliExpress and other vendors. I think we do have a couple in common that we use, like Misumi. We use that for extrusion. They've got really, in my opinion, excellent pricing on that. And I think we both use Ziltech. But why don't you talk about some of the challenges you've run into in sourcing parts?
Yeah, so being someone who's always a little bit more conscious about budget, um, personally, I tried to find didn't want to spend too much time hunting down the absolute cheapest part anywhere, but I did have some issues. I started on Amazon trying to find things there. I do, enjoy getting things a little bit quicker than average. So I did look for a lot of parts there. I ran into a lot of problems where I couldn't find certain things I needed though. So for like on Amazon, you can get the SKR boards, and you can get steppers and things there. You can get lead screws. You can get a lot of that stuff on Amazon. Yeah, as far as like, I'm trying to remember. I believe I had a few things from Banggood. I think I got my lead screws and power supply from there. But those things are available on Amazon. They're available. Ziltech has power supplies as well. But yeah, Ziltech's a big one. They're a U.S. based company, so if you're in the U.S., I recommend checking out their stuff. I mean, anything you pretty much need to build a printer, they probably have it. When it comes to like the electronic side, they don't have some of the SKR boards and the stepper drivers and things that we recommend using. But they do have a lot of the other pieces, and I definitely agree on Misumi. I think as far as extrusion goes, it's going to be hard to find someone that's going to give you a better price, and their turnaround times are pretty good. They're also, I believe, Elkhorn, Illinois, or something of that nature.
Elk
So,
Grove
or not
Village. Yeah.
Elk Grove Village.
Yep.
Yeah, sorry. Yeah, and so I think that's always good as well. So I like the U.S. companies, of course. It's easier to ship to here. If you're overseas or in another country, like sometimes the shipping times from China aren't as bad. So definitely look there. I mean, if you absolutely want to save the most money, you're probably going to get better pricing there for a lot of this stuff. But you are going to wait, maybe a month plus to get the parts. So it's definitely up to the person doing the printer. And like you said, you can find alternate parts. You don't have to buy the exact part that we found or that we recommend. You can always find something equivalent. So steppers are a huge one where there's a million different people that make the same 1.8 degree NEMA 17 stepper motors, and you get bigger ones, you can get pancake steppers. So I think that's a big thing is make it your own, decide what you want to do with your printer, and then kind of go from there. So if you want to have dual extrusion, single extrusion, color changing things like external, what do they call it, MMUs or whatever they are. to do the different colors. So I think that's the fun part about making your own is you're not stuck with something that someone else designed. You can kind of design it and then go buy the parts and use this as a guideline as opposed to a strict rule.
So let's talk for just a minute about the skills necessary to build this printer. I know that um, obviously the videos make it look easy. You've got time compression that works to your advantage. I'm showing literally the steps of building the printer, but let's really talk about the skills overall. I think um, obviously you're going to need some mechanical skills of being able to one, use your existing 3D printer to get the parts printed. I think after that you need to be definitely familiar with using extrusion, um, being able to know how linear rails work, just a little bit of background in at least some printer assembly. I know that I've mentioned to other people the C201's probably a really good video series to watch to understand how a 3D printer works overall. But I think there's also the electronic side. Do you want to talk about that a little bit, Nick?
Yeah, so I mean, some of these things are going to require a little bit of soldering. I know, let's think here. So as far as soldering goes, I know, the bed is one thing you'll probably have to solder. Now that's a bit of a chore. If you can find a bed that has pre-soldered connections or more of a plug-in connector, I definitely recommend that. If you're not super good with soldering, if you can solder though, I would go ahead and just get the Ziltech bed, and get some wire. 16 gauge should do for the most part. If you want to go 14 gauge, I think that's not a terrible idea either. Now, then after that, a lot of stuff is you can use crimp connectors. You can use just solder wires together if you want. I think there's a lot of different options on the wiring and things of that nature, but definitely understanding electronics to a little bit of an extent. Know your positives and negatives, things like that. Make sure to double check things before you plug them in. I highly
Regional
recommend.
AC wiring, I think, is helpful too. So for your
Mhm.
region, being familiar with your wall voltage,
Oh
because
yeah.
that can be downright dangerous, especially if you're in a country that's at 220 versus 110.
Mhm.
Um, those mains voltages can definitely hurt you.
Yeah, definitely, definitely. So a lot of what we've done on this printer in all of our builds has been DC power through a power supply. So your mains comes into that, and then after that you're at a pretty fairly safe 24 volts, I would say. 24 volts isn't going to mess you up too bad, but definitely mind what you're doing. And that 24 volts will do a lot more damage to boards and things if you do short stuff. So be mindful of that. Keep things unplugged when you're not trying to test it. And then, every time you go to plug it in or power it up, just kind of double check everything. I triple check everything every time. As experienced as I am, I'm not, free from making mistakes. I'm human just like everyone else. So it's always good to just double check. Don't get in a hurry. There's no need to be in a rush. Take your time, because one mistake can set you back a lot longer than taking the extra 2-3 minutes to double check everything. So, and then just a quick thing that I found and has just been super good is these little ferrules that you can buy. So they're little caps essentially you put on the end of the wire. They have a little sleeve on it, but you take that, you stick it over the end of the wire, and you crimp it, and now you have a nice solid hard end that can go into these screw terminals and things like that. So those are definitely a recommendation. You can buy a whole set of them for like almost nothing. The crimpers are pretty cheap. And you can find those on Amazon or wherever as well. So, when it comes to the electrical stuff, I would definitely buy some of those. They've been a lifesaver, just making things way easier to put together. And then, spade connectors and things of that nature as well, and little fork connectors can be useful as well. So there's a lot of that stuff on the printer for connecting the
Yeah,
bed
and I
and
can
power.
definitely Yeah, I can definitely put a link for that in the description as well
Yep.
because those I use those connectors now religiously, and they really do make a difference. It's just
Hmm.
so much easier to connect things and screw them together.
Yep. Yeah, and I think as far as tools and stuff for doing this build, I mean, you definitely want to have an assortment of hex screws, or hex not hex screws, hex screwdrivers, or bits. Either one. Um, let's see what else. Soldering iron, obviously. Um, Trying to think, like crimpers of various types. So, like I said, you can do crimps, you can solder things together. It all depends on how much you think you're going to be changing things. Some people build these printers, never touch them. They just run them, run them, run them. And in that case, soldering is probably preferable. I tear things apart constantly, so I like to have some disconnection points. So you could use, in a lot of cases, you can use simple things like DuPont connectors. They have these like little JST connectors as well that a lot of people use. So there's a lot of different options as far as that. You can use screw terminals, that kind of thing. You can kind of make up your own boards. So you could have little boards that, you screw in terminals and things like that that you solder together yourself. So yeah, I think, having soldering is a big one, just to kind of be able to put wires together when you need it. I mean, some of the stuff isn't too big a deal. I would say when you start getting into like the heat bed wiring and things, though, you don't want to just be twisting things together and taping it up. Definitely not the best idea. You want to keep those strands as good as, or as connected as possible. So solder is definitely the way to go on those kinds of things. But some of the digital signals and things aren't that high current, so you can get away with that sometimes.
So I think overall, the printer, as far as skill sets, I think you've got some mechanical, you got some electrical. Being able to troubleshoot's good, and then a little bit of software as well, just being able to compile the firmware. But I would say that this printer, and uh, correct me if you feel differently, but I don't think building the CoreXY printers any significantly different or harder than building, say, the C201 or any Cartesian printer. I think once you get to the point that you're building a kit printer, you're obviously going to have a much deeper understanding of the mechanics of a 3D printer. But I think overall, it's not something, if you're a person that can um, build projects, even small projects, mechanically and familiar with those electronics, I think you should be able to tackle this printer and this project. I don't feel like it's um, uh, too difficult for most people that would consider themselves makers these days.
Yeah, and I think, the Core XY, the biggest thing is getting everything aligned right, so we've kind of taken care of that bit. The parts are designed such that things will align once after you've got them all put together. So the idea is that, all of that mess is kind of taken care of, and then it's just a matter of kind of putting it together. So, and then, making sure your belts are tight is obviously key for the Core XY. So that's a big thing. And, we've got a few different points you can tension with the design. So that's key. Gives you a little bit of flexibility in how you get those belts tighter, and you can kind of fine tune that a little better. And just little things like that. Trying to we take some of that out of it, but you can learn along the way. You can kind of see how it's designed. You can see the way it's the belt is looped around, and how that works, and then get a feel for kind of how the steppers and stuff work as well. If you just kind of manually move it around, it's kind of neat to see. If you go in the X, how do the steppers move? If you go Y, how do they move? Because they kind of have to move together. And I can't remember exactly if it's together as X or if against as X, but I think it's together as X and against as Y. So it's kind of interesting. It's a neat thing once you get it together to kind of see how the firmware manages that, and it can move, in both X and Y by moving the steppers in just certain ways, and it's really neat. Yeah, a lot of that stuff is kind of taken care of. So as long as you print the parts, or if you want to modify them, just keep that in mind that a lot of the dimensions are such that everything kind of stays aligned. So that's the key with the Core XY, is everything's got to be aligned and in parallel and things like that. For the most part, you can be off a little bit, but for the most part, you want to keep everything pretty straight.
And one of the other things we talk about creating this printer. So I think two things. First, this printer was not designed by either one of us to be a cheap, economical printer. I mean, it was really designed to be a quality printer, to put something together that is a workhorse that really produces great prints, and that's really what we have. But at the same time, when we talk about that, there's really no reason in this design that people that are watching this video could do substitutions on parts. So I know that we use the SKR boards because it's convenient, but really no reason you couldn't use a ramps board, really no reason that you couldn't use a Melzi or any or a Duet, any number of 3D printer boards that are available out there. If you have that experience, you certainly should leverage that when developing this printer. So it's something that is, again, a little bit more customized to you, but you may be more familiar with a different type of board rather than the SKR or maybe an MKS.
Yeah, no, that's a good point as well. And like you said, we like the SKRs, but especially if you're going to be looking at dual extrusion, you can look into some of the, Big Tree Tech also has other boards as well themselves, or you can look at other boards entirely. I know a lot of people like the Duet boards because they come with kind of built-in web servers, and they're kind of an Octoprint plus, Marlin wrapped into a neat little package. And more power to them. For what I do and how I like to use my printer, I prefer kind of the more open source approach with Marlin and Octoprint, but to each their own. But I think you can get more powerful boards, and the other thing too is it's pretty expandable as well. I mean, now that you've built it, you know how it's put together. You're going to learn through that experience, especially if you're a bit newer to printing, or at the very least this is your first printer you're building. I mean, there's a lot to learn along the way, and once you kind of gain that knowledge, you can take that and expand your printer, because now you understand how to how to make the changes in the firmware, to add the configurations, to add an additional extruder, or add some additional features like filament runout or something of that nature. So I think it's a learning opportunity, and it's a fun thing to do. And like you said, it's not the most budget printer on that's out there. So I think, but again, like you said, you can substitute things to bring the cost down. And again, if you source your parts from certain places, or look for things that are kind of a good price, and just do your research, you can definitely get the cost down and get a lot of the same effect, because a lot of the good of it is in the design of the frame and the CoreXY and things of that nature, and then you've got a bit of that is from the electronics as well. So 32-bit board is definitely a recommended thing, and if you can get the TMC steppers, I definitely recommend it as well. Your ears will say thanks.
So I hope today's video was helpful for you. It is really designed as kind of an informal discussion about the way that you can source your parts, some of the challenges you're going to run into in building this printer. And I think it's a printer that most people should be able to build if you've got some solid soldering skills, have worked with electrical and electronics before, and can do some really basic assembly with 3D printed parts. I think it is something that you could probably even get done in a weekend. So we're going to be releasing the next video in this series, which will be the first construction video of the frame, in the next day or so. If you'd like to help support this project and the channel, please consider becoming a Patreon. Our members get access to exclusive content and early access content on the channel, and they already have access to the bill of materials for the printer. It's a work in progress over the course of the videos, but they already have early access to that and some of the models. So it's a good way to get a jump start on the printer development if you're going to build one yourself, and a great way to support the channel. Now, if you run into any questions about this, please feel free to check out our Discord. There's an X301 channel dedicated to questions to the community on how to build the printer or general 3D printer building skills as a whole. So if you enjoyed today's video, make sure you mash that like button, and don't forget to share and subscribe. We should have our next video out here very soon, but make sure that you subscribe and click that bell so you get notifications so you don't miss the moment that the next video is released. So with all that said, I want to say thank you for watching and all of your support on the X301's development over the last year. It's been really great seeing all the support in our channel Discord, and I want to put a shout out to all of our Discord MVPs and everyone else who's been very supportive through the development of this printer. So I'm very excited to be releasing our new videos and the build in the next coming days. So with all that said, thank you again for watching, and we'll see you next time.